Welcome to another Chao time. This is an important one. It's called Systems of Equations. This one is important because, this is lesson 6, page 420 if you're following along the book. This one is important because this is the meat of the project that you're doing on accounting efficiency. So a system of equations is a collection of two or more equations with the same set of variables. The solution for a system of equations is where all the equations can be solved by the same domain and range values. So for example, let's say we have this situation here where, I don't feel like making up a situation, but let's say there was a situation where you multiply x by 5 and you get your output y. And in the same situation, there's this other thing going on where you multiply 2x and then you add 30 and that gives you y. Well, this is going to give you two different graphs, right? If we graph this one, it might look like this. Oops, that didn't go through the intercept like I wanted it to. It might look like this. So this is the first graph. And then for the second graph, it has an intercept of 2 and 30. So let's say 30 is up here and slope of 2. So as you can maybe see here by what I've done, here we go. There is a point that the two lines cross, and that is where the solution is the same, right? And that is 10, 50 in this example. If we put 10 into x for both of these, y will be 50 for both of them. And so this coordinate is true for both of these equations. And that is the solution for the system of equations. Okay? All right, so let's take a look at an example. Here we have y equals x. So I'm just going to get out orange, let's say. And we're going to graph that. Y equals x. Here we go. Well, that didn't start out right. Y equals x. Yeah, I'm just going to start here. Looks like that. So that's that one. And then we'll use this kind of deep purple. You can't even tell that's deep purple, huh? I'm gonna use a different color. How about this brighter purple? Does that one work? Yeah, there we go. And then we'll graph this one. This one has an intercept of 4. 1, 2, 3, 4. So that's right there. And then it has a slope of -3. So it goes down 3 over 1, down 3 over 1 right here. So we're just going to draw that. So where does the system meet? It meets right here. Right? Can you guys see that? I'll use black. It meets right here. That's where the two lines cross. And that's at 1, 1. So this is the solution to this system of equations, and we've figured that out by graphing. Your turn. Solve this system of equations by graphing. So you're going to have to graph in your own notebook and then put in an answer. So here we have an intercept of 2 and then a slope of 1. So this one is going to look like this. And then we have -4, which is 1, 2, 3, 4 right here. And then a slope of -2, which means here. So there we have it. These two meet right here, which is 0. I'm sorry, nope, that's not right. negative 2, 0. That's this coordinate right here. And that is now solved. Okay, so let's see this in some sort of action in perhaps real life. Nina and Harrison, let's say they're both selling popcorn because, they want to raise money for some reason. And Nina sells 3 times as much popcorn as Harrison. So Harrison also sells 12 fewer popcorns than Nina. Well, in order to solve the system of equations, we have to first write the equations, right? So we'll use, let's say X is Harrison and Y is Nina, because we have an X and Y axis, right? It doesn't have to be. X could be Nina and Y could be Harrison. In this example, there is not a independent and dependent variable, right? Harrison does not depend on Nina selling popcorn, and vice versa. Nina does not depend on Harrison to sell popcorn in order for her to sell popcorn. So there's not actually a independent and dependent relationship here. I just chose to do it this way. Anyway, okay, I spent a long time talking about that. So Nina sells 3 times as much popcorn as Harrison. So 3 times Harrison equals Nina, right? We know that from that sentence. The second sentence says Harrison sells 12 fewer than Nina. So Nina, Y, minus 12 equals Harrison, right? So now we can graph these. The first one is a proportional relationship, or a constant of variation, or direct variation. Any way you want to look at it is fine. Here, we have no, we have a y-intercept of 0, so it's going to cross right there, and then it's going to go up 3 and over to the right 1. So it's going to look something like this. We also know that he sold 12 less than Nina, right? So what we'll do here is we will use a different color. We will add 12 to both sides, and that gives us y equals x plus 12. Okay, so our intercept is at 12. I don't think there's 12 here, right? So we're going to have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 we'll just say is about right there. And then this is going to go up into the, no, this is going to go off the graph too much. I'm sorry. We're going to have to relabel this thing here, and this is going to just take a little bit more time. And this happens sometimes with graphing. We just have to go with it. So instead of going by ones, let's just go by threes. So this will be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And then we'll go the same here. 3, 6, 9, 12, 15, 18, 24, 27, 30. Did I miss one? 3, 6, 9, 12, 15, 18. Yeah, I did. Oh, how embarrassing for me. 21, 24, 27, 30. Okay. So let's go back and graph that one again, which had a y-intercept of 0, and then it would go up 3 and over 1, up 3 over 1, up 3 over 1. So it would end up here at 9, 3, right? So we will graph this one like that. Okay. That's not very good. I can do better than that. Here we go. Okay. Now we will graph this other one, which has an intercept of 12, which is right here. And the slope is 1, so it's going to look... Oh, that's horrible. Let's use this orange. So this one is going to look like this. So this is where they cross, which is at 6:18. So that's the answer. That's our solution. That took a long time. Holy cow. So what does the solution mean? It means that Harrison, X, has sold 6 popcorns and Nina, Y, has sold 18. And we know that because of these two pieces of information. As you can see, the graphs have other answers, right? There's a lot of other answers here, but none of these are the right answer because it doesn't fulfill both of the equations, which it needs to in this situation, because all these other equations, they're only true for one. I'm sorry, all these other points are only true for one of the two sentences. Okay, your turn. How long has this gone? 11 minutes, holy cow. A school has twice as many new students as existing students. So we have, let's make X existing students. I'm going to change color because I don't like that color. And then we'll say Y is new students. So a school has twice as many new students as existing students. So there's more new students than existing students, right? More new students. So we're going to take 2 times our existing students to get our number of new students. The number of new students, Y, is 22 more than the number of existing students. Okay, so here again, we're likely going to have to relabel this. So let's do, let's do this by 5s. 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. Okay. So the first one we can do is this one because this is already in slope-intercept form. No, they both are actually. Great. So we'll start here. It's a constant of variation, and it's going to go up like this. Right? Because it's going to go up by 2 every time that it goes to the right 1. And then the second equation has a y-intercept of 22, which is about right here. And it's going to go up by x. 1. So it's going to start here, and it's going to, that's not the line. Yeah, it is. My computer didn't keep up. Okay. And it's going to go up like this. Something like that. Okay. So here is our intersection. And here you see kind of one of the issues with graphing. We don't actually know where that's crossing because it's crossing kind of in the middle of nowhere, right? it looks like it's crossing at maybe 22 and 30, 35, 40, 40, 47, maybe 30, 22, 47. No, that doesn't make sense because that wouldn't be twice as many. If it was 22, it could be 22, 44. Is that it? 22, 44. 22 plus 20. Yep, that's right. So we kind of had to do a little bit of guessing there. I just guessed it could be 22. I put 22 into here and I got 44. And then I put it into here as well and still got 44. So that is the answer. But as you can see, graphing doesn't always get us a very precise solution, which is a good segue into our lesson next week. Explain what it means. It means that there's 22 existing students and 44 new students. This school is growing fast. Solve the system by graphing. Here we have -2 and x. Oh, why does it keep doing that? -2 and 1. This one, the slope is 1. The intercept is -2. That's how I got this. Here's -2. It's just going up by 1 each time and over to the right 1. Here we need to move everything that's not the 3 or the y over, right? So we'll subtract x on both sides. So 3y equals -x plus 6. And then we'll divide by 3 on both sides. Get y equals, and then we'll have to distribute this division. And that'll be -1 over 3x plus 2, right? I took -1 x, and I divided by 3, and I got -1 over 3rd x. And then I took 6 and divided by 3, and that gives me 2. So that the intercept here is 2, and it's going to go down 1 over 3. So look at that. It crosses right there. We can already see that. And so I'm just going to graph the line just so we can see it. There it is. That's where it's solved. Your turn. Here again, we have 1 in slope-intercept form, 1 not. So we need to subtract x on both sides. 2y equals -x plus 8. Divide by 2 on both sides. And y equals, and here again, we're going to distribute this division, right? Just like we can distribute multiplication, we can distribute division. So -x divided by 2 equals -1/2 x plus 8 divided by 2 is 4. So now we can graph it. Plus 4 is right here. And then the slope is -1/2. That means it's going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And then we're going to draw a graph. This video is getting a little bit too long, so I'm going to try to stop it pretty soon here. The next one is -3, which is right here. That's the y-intercept, and then the slope is 3. So it's going to go up 3 over 1, up 3 over 1, and you can see it crosses right there. Perfect. So here the solution is 2, 3. That is our solution. All right. Sometimes there's one solution, which is everything that we've seen so far. There's just been one solution, and it looks like this. This happens when the slope is not the same in the two equations. So we can look back at any of our previous examples here. The slope was 3, and in this one it was -1/2, right? Here the slope was 1, 1, and here the slope was -1/3, right? If the slope, is not the same, then you will get one solution, just like this. If the slope is the same, which we haven't looked at yet, if the slope is the same, then the two lines will have the same slope and they will never touch each other. They will have no solutions. Another possibility is that they have the same slope, so both of these have the same slope, but this one even has the same y-intercept. These are the same line, and there's an infinite number of solutions. So let's take a look at these two examples. Here we see that both of the slopes are 1, right? The slope of both of these is 1, but the intercept is different. This one is 4 and this one is 0. So these lines are never going to touch. One is going to pass through the origin. The other one is going to pass through 4. 1, 2, 3, 4 right here. And these lines are never going to touch. This one has no solutions. Your turn. All right, so here you see the slope is 1/2. We're going to subtract x on both sides, and that will give us -2y equals -x plus 2. We're going to divide by -2 on both sides, and that'll give us y equals 1/2, because this is a -1. -1 divided by -2 is a positive 1/2, x minus 1. You can see here these two equations are the same. They have the same slope of 1/2 and the same y-intercept of -1. That means this is going to have an infinite number of solutions. All right, I apologize for this crazy long video. Here's your must-do. Have a good day.